Let's go AP Chemistry. This will be on the class page as soon as we're done with it. Now, I want to kind of summarize where we are and where we're going and what we're going to do today. And then I'm literally only going to talk for possibly 10 minutes, and then I'm going to set you to task. And then maybe before, like 5 minutes before class ends, we'll take a picture for Joe Snedeker and his pointing thing. So anyway, we've been talking about naming chemical compounds. So obviously, this is the last day or two that we're going to be spending on this. We'll wrap it up, and next week we're moving right into balancing equations, learning the reaction types, and stoichiometry. So next week we dig into some of the meat of chemistry. So we've been spending our time here, and ionic compounds, of course, made up of cation and anion, and we talked about two different kinds. We talked about binary. For example, sodium chloride, just made up of two elements. Sodium is a metal, group 1, +1 charge. Chlorine turns into chloride. As we know, it gets a -1 charge. Very simple. So we had two types. We had the transition metal ones, TM, I'll call transition metal, and they have variable charges, and we have to indicate that using the Roman numerals in parentheses. Also, there were three other elements: tin, lead, and antimony that could get multiple charges. The exceptions, and again, this will all be online, the exceptions are zinc with an always +2 and silver with +1. So those don't need the Roman numerals. And the other type we had were main group. I'll just call it MG, main group metals. So things like the alkali metals, the alkaline earth metals, um, aluminum, gallium, uh, things like that. So these are not multivalent. Now let me explain what that word means. Multivalent means more than one charge. Okay, it's just a chemist way of saying that. So there's sort of like a little flow chart of where we're at so far, and then uh, a little bit later today, I'm going to talk about covalent compounds. And we did mention things about acids yesterday. We mentioned naming acids. I'm not going to make a big deal about that. We're going to practice those names as we use the acids. But I would like you to know, for example, that HCl is hydrochloric acid, H2SO4, HNO3. These are the big ones that we're going to be playing with in lab. Hydrochloric acid, sulfuric acid, nitric acid, and we'll get to other names as we need them. For example, the organic acids. All right, let me erase this. And like I said, I have a couple more things to tell you, and then we're just going to work on some stuff today. Very nice, easy day. Get us all set for a little naming quiz on Friday. Oh, excuse me. Pause. Phone is ringing. Sorry about the phone call. So, I need to talk to you about another type of chemical compound based upon ionic compounds. So guys, pay attention to this because lab after next, this is what we're going to be playing with, these types of compounds. They are called hydrates. Hydrates. And what they are ionic compounds like this one. And if we had to name that, we would call that copper 2 sulfate. We should be able to do that by now. But, and to kind of just be very simplistic here for a minute, picture ionic compounds with cations and anions arranged, like, for example, on a three-dimensional crystal type of a shape, where we have anion, cation, and they're bound together through these electrostatic forces, something like this. So again, this is very simplified. We're going to get into this a lot more in a few chapters. So we have some sort of a three-dimensional structure. You don't have to draw this. Some sort of a three-dimensional structure, and it goes back and down and around. And all these ions, these anions and cations, they're all arranged on this crystalline structure. Now, if I can get water molecules to kind of be stuck inside of here, well, then we have something called a hydrate. And we represent that by a big dot and a number and then a water. Okay, H2O is water, of course. So we read this as copper sulfate pentahydrate. And these are very interesting compounds because those water molecules that are, I have 5 water molecules for every 1 copper sulfate unit. And they're kind of stuck, like I said, inside of that crystalline structure. So when I heat that, something really kind of interesting happens. This chemical compound, copper sulfate pentahydrate, is a very beautiful blue color, very much like this bottle or the color of the marker. But when I heat that, here's a symbol for heat, little triangle, something happens. The water, and when you see this, I think you'll enjoy this, the water gets driven off. It gets driven off as a gas, vapor. And what's left over is this is the hydrate, this is the anhydrous portion, anhydrous, that's an R, or anhydrate, whatever you want to call it, and that means the water has left. So this is like a grayish white color, and we've driven the water out, and those water molecules that were originally part of the crystalline material, when they go away, the color changes. And it's interesting why that happens. But anyway, we're going to do an experiment very much like this, where we calculate the change in mass as we dehydrate these chemical compounds. But these hydrates are very common, and to name them, it's really easy. I just have to give you a list of prefixes that we're going to use to name them. So for the number 1, like if there's 1 water, we would call that mono. 2, di, like Princess Di, keeping with the royal theme. 3, tri. 4, tetra. 5, penta. 6 is hexa. 7 is hepta. And 8 is octa. 9. What do you think 9 is? Anyone have an Italian grandmother? Nona. Nina?
Yeah. Oh, that's like it's a girl.
Nona. My Nona. And 10? What do you think 10 is? How many years? What is 10-year unit called? What?
10 year?
A 10-year, a decade. So, deca. So these are the prefixes that we'll need when we name these things. So you might have something like this. You might see MgSO4 dot 7H2O. How are we going to name that chemical compound? Simultaneously making a YouTube video. What's Mg? Magnesium sulfate. Good, you got half of it. Magnesium sulfate heptahydrate. Good. This is commonly known as something called Epsom salts. You can soak your tired, sore feet in that.
Bunions.
They're bunions. Or your hemorrhoids, whatever. I don't know. It's going to be on YouTube. So, I'm the Snedeker of chemistry. Oh, I didn't mean to erase this. I got to write these because we're going to save these here. So di, tri, tetra, penta. So these are easy. I can give you these. The only thing I'll be conscious. I want you to be conscious of if this is a transition metal, which magnesium isn't. But if it's a transition metal and it gets more than one charge, make sure you put the parentheses. Okay, nothing to it. Now I want to take a minute. Everyone have this in their notes. These names. All right, good. I want to talk about the last thing that we need to address, and that's called covalent compounds. Now, ionic compounds always had a metal and or ammonium as the cation, a metal cation, and an anion, either right from the periodic table or a polyatomic. Covalent compounds are made up of two or more non-metals. Okay, and they form bonds by sharing electrons. We're going to get into that, Lewis structures, all this stuff in about, I don't know, a few weeks. But the interesting thing about covalent compounds is that you can have a variety of them. Let's take a look at something here. If I had an ionic compound made between sodium and chloride, there's only one combination you could have. You could only have NaCl because the plus one charge and the minus one charge get together, cancel each other out. You'll never see this Na2Cl or NaCl2. Never, 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 because these are ionic compounds and they form in those definite ratios. But covalent compounds, since they're sharing electrons, you can have a whole bunch of things. You could have CO2. You could have CO. You could have NO2, NO, N2O4, N2O. These are all compounds made up of nitrogen and oxygen. These are compounds made up of carbon and oxygen. You could have, let me think of some other ones. You could have PF4, or sorry, PF3. You can have PF5. These are two or more nonmetals combining in different ratios. And we somehow have to differentiate between all of these chemical compounds. And P4O10. What the heck are these things called? We're going to learn that now. There are always going to be some sort of carbon oxide. Remember, the first element keeps its name, and the second element changes its name to ide. So some sort of carbon oxide, nitrogen oxide, but phosphorus fluoride. But we have to go ahead and we have to say, if I'm trying to differentiate between these two, or between these four, or these two, how do I name them? And that's where these mono, di, tri, and all of these things come into play. Because if we're just talking about carbon oxide, this one carbonates your soda, and this one will kill you if you breathe it in. So there's two very different have two very different sets of chemical properties. Uh, some of these nitrogen compounds, these nitrogen oxide compounds, uh, will cause some damage to you. They're very toxic. And some of them, like that one, the dentists used to use for laughing gas. And in New York State, as a matter of fact, if you're under 18, you can't buy whipped cream. I think I told you that because it contains that as a propellant. So if you're like inhaling the whipped cream can, you're going to get like a little woozy head or something. So of course, New York with their over-regulation on everything. Yes, I'm saying that on YouTube because I don't care. Um, you got to be 18 to buy nitrous oxide.
I heard that on the news.
It's crazy. Yeah. Yeah. I You don't want to know what's going on through my head most of the time. So, how are we going to name these things? We use prefixes or prefaces, if you want to say it correctly. So let's take a look at a series of chemical compounds. CO and CO2. This one It's a carbon and one oxygen. So we call it carbon monoxide. Mono, well, if we have mono and then oxide, we just drop the O there. Instead of saying monoxide, that sounds a little odd. So we say monoxide. And you might be saying, hey, why don't you call it monocarbon monoxide? Well, part of the rule is if the first element here is there's just one of them, we don't have to specify that there's one. So for example, well, let's look at this one. This is carbon. What do you think this is going to be? With two. Carbon dioxide, right? Carbon dioxide. All right. Easy. I mean, you can't ask for an easier way to name things. Let's take a look at some others. These crazy nitrogen compounds. NO, NO2, N2O, N2O4, among others. Now remember the rule, if the first element, if there's only one of them, we don't have to say mononitrogen, but we would say nitrogen monoxide. Monoxide. And I'm running out of room here. Now this one, what are you going to call this one? Nitrogen dioxide. Yeah, nitrogen dioxide. And I think I erased N2O. Now this one, the one that's illegal in New York State, N2, my first element now has two. So this is where the rule has to change a little bit. We have to tell people that there are two nitrogens. So we call this dinitrogen, one oxygen monoxide. Dinitrogen monoxide. Now you tell me, how about N2O4? What are you going to call that one? Dinitrogen tetroxide. Yeah, you guys got it. Dinitrogen tetroxide. And again, you drop that A since oxide begins with an O. We drop the vowel on the prefix. So that's it. Those are naming chemical compounds, and we have a little work to do. And the rest of the day is going to be just working on this stuff. So I'll post this 17 minutes. I only wanted to talk for 9, but that's okay.